Okay, hello. This is Math 12, section 9.1, testing the difference between the two means. So we are using the two population this time. So using the z-test first, okay? So in the previous chapter, we use a z, t, and chi-square test to compare a sample mean, variance, and proportion to specific population mean variance, or proportion to decide whether or not to reject the null hypothesis. Now, we will use the same basis step for the hypothesis testing to compare the two sample means, proportion, or variances. When comparing the two means, we may be able to use a z-test, but where the t-test is used, we must decide if the sample is independent or dependent. So the z-test is used to compare the two proportion. So we will learn to use a new test called the f-test to compare two variances. Suppose a researcher wants to study whether there is a difference in the manual dexterity of the athletics and band members. In this case, the researcher question is, does the mean score on the manual dexterity test given to athletics differ from the mean score for the sample test when given to band members? The researcher is interested in comparing the mean of the two groups, not in knowing if the mean of all the athletics and band members together differs from the specific values. So thus each group mean is considered separately. So mu1 is about mean score for the manual dexterity test of the athletics, and the mu2 is the mean score of the manual dexterity test of the band members. So hypothesis h of 0 is mu1 equal to mu2, and then h of 1 is mu1 is not equal to mu2. So if there's no difference between the means, the difference between between them, there will be a 0. So if they are not different, subtracting the one from the other will not be equal to 0. So then the hypothesis becomes the hypothesis equals mu1 minus mu2 equal to 0, but h of 1 is another way is not equal to 0. So either method starting the hypothesis correct, so we will use the first method. So we are using this method. All right, next page. So hypothesis testing whether there is a difference between the means of population or not may also be one tail. So which is a right tail, which is greater, and then the left tail is the less than for between the two means. Two samples can be collected such they are independent or dependent. So definition of independent samples. Two samples are independent when the subject selected for the first sample in no way influenced how two subjects are selected for the second sample. So for example, a researcher might select a group of 100 people and random assign them in two groups up to 50 people each in order to test the efficiency of the new drug. Excuse me. One given is given the new drug, and the other groups given a placebo. The two samples are the independent. Excuse me. The dependent samples. Two samples are dependent when the selection of the subjects for the first sample in some way does influence to the selection of the subjects for the second sample. So for example, suppose the researcher wants to determine if the average temperature of the person's right foot was different from the average temperature of the one left foot. The temperature of the right foot of each person in randomly selected from the 25 people would be measured. Then the temperature of the left foot of each of the same people would be measured. The sample for the right foot temperature influences the selection of the subject included the second sample. So the samples are the independent the dependent. Sorry. Assumption for the g-test to determine the difference between the two means. So number one, both are the random samples. And then the sample must be independent each other. And then the standard deviation of the both sample must be known. And if either of the sample size is less than 30, the population must be the normal or approximately normal distributed. So theory behind the testing the difference between two means is based on the selecting the pairs of the samples and then comparing the means of the pairs. It is not necessary to know the population mean for either population. So for this test, all possible pairs of the samples are taken from the population. The means for each pair of the samples are computed, subtracted, and the differences are plotted. if the both population has the same mean, the most of the differences will be 0 or close to 0, with the occasional large, negative, positive difference due to chance. The plotted differences will be the shaped like a normal distribution and have a mean of the 0. So variance of the differences x bar 1 minus x bar 2 is equal to the sum of the individual variances x1 and x bar 2. Thus the sigma sub 2 sigma square of the sub 2 number of the difference, which is same as this, and then we just write it this way too. So we got that's how you find out the variances. Okay, so this is the z-squared you can use for the testing. So before the basic format of the hypothesis testing using the traditional method, number 1, state the null and alternative hypothesis, identify the claim. Step 2, find the critical values. And then number 3, compute the test statistic. And then number 4, make a decision, reject or do not reject the null hypothesis, and then summarize the results. Okay, so let's look at the example. So home prices, a real estate agent compares the selling price of the random selected homes in two municipalities in southwestern Pennsylvania to see if there is a difference. The results of the sampling is Scott and then Lingonier. So there's a mean price is a little bit different. And then the standard deviation is here. And then that's the number of the houses they checked. Is there enough evidence to reject that claim that the average cost of the house in the both location is the same? We use the alpha equal to 0.01. So step 1, we need to state the null hypothesis and the alternative hypothesis. Okay, so h of 1 equal to mu1 equal to mu2, which is that's the claim, and also h of 0. And the h of 1 is a mu1 is not the same as a mu2. So find the critical values. So since alpha equal to 0.01, but we are using this two-tail. So we need to find the alpha over 2, which is 0.005. So when you use the z-table, which is the area between the both n is 0.005 and 0.005, and then z-square you on that is negative 2.58 and the positive 2.58. So if you have a test statistic for the next is that come out as less than negative 2.58 or more than 2.58, and then we will reject the null hypothesis. Okay, so we compare the test statistics. So z is equal to x of bar 1 subtract the x of bar 2, subtract the mu sub 1 minus mu sub 2 over sigma sub 1 square and 1 plus sigma sub 2 square and 2, which is, if I plug it in, 93.430 subtract 98,000, not points, 1,000, sorry, 43 over square root of 5,602 square over 35 and plus 4,731 square over 40, which is come out as negative 3.823. So now 3.823 in the curve is going to be about here, negative 3.823. So which is it falls into the critical region. So on the step 4, we need to reject the null hypothesis. And then if you use a z-score to find the p-value, so p-value method, it's about to come out as a 0.0001, and then which is still compared with the alpha, which is a 0.01. This works too, so you still need to reject the null hypothesis. So as a summary, you have to say that there is sufficient evidence to reject the claim that the mean selling prices of homes in two municipalities in southwestern Pennsylvania are the same. All right. Okay, so let's look at this next page, okay? So next page, they use the p-value method for the hypothesis test to follow the same process as in the chapter 8. Steps for the hypothesis testing for the p-value methods are: step 1, state the null and alternative hypothesis and identify the claim. Number 2, compute the test statistic and then find the p-value. Make the decision, reject or do not reject null hypothesis, and summarize the result. So example 2 is talking about age of the college students. The dean of the students wants to see whether there is a significant difference in ages of the resident students in commuting students. She selects a random samples of 32 students from each group. The age are listed below. At the alpha equal to 0.05, decide if there is enough evidence to reject the claim that there is a difference in the age of the two groups. So use the p-value method to assume that the sigma sub 1 is a 3.68 and then sigma sub 2 is 4.7. So resident students and commuter students, they have different groups here, okay? So in step 1, we need to state that as null hypothesis of mu sub 1 same as mu sub 2. And the alternative hypothesis is a mu sub 1 is not same as a mu sub 2, but this time is alternative hypothesis claim. So we need to find the test statistic. So in order to find the test statistic, we need to find the x bar sub 1. We use the first resident students groups and then find the x bar, which is a 22.2. And then you need to find the x sub 2 bar, which you use a second group, which is a commuter students, to find the mean. It's a 22.3. And then you also need to find you already have the sigma, which is 3.68 from population, and then sigma sub 2 is 4.7. Okay, so the test statistic, the formula is x sub 1 bar minus x sub 2 bar. Subtract mu sub 1 minus mu sub 2 over sigma sub 1 square over n1 plus sigma sub 2 square n2, which is 22.2 subtract 22.3, but mu sub 1 minus mu sub is always 0. And then the 3, and then square root of 3.68 square over 32 samples, and 4.7 square over 32 come out as negative 0.09. So you need to use the z table to find that as find the p-value with p-value is going to be twice of the area here. So when you're looking at the here, so you have to find the actually use the z-score, which is let me see it. Try to use it as a z-score, so negative 0.09. And so it's going to be twice of 0.4641. So when you compute this, twice of 0.4641, and then I got 0.9282. Okay, so and then you compare with the alpha. Alpha is a 0.05, which is not sure, right? Okay. So on the next one, we don't reject the null hypothesis. So conclusion means there is not enough evidence to support the claim that there is a difference in ages of resident students and commuting students. Okay, so all right, the next one, we can also prove the hypothesis by the confidence intervals. So when the researcher wants to test whether the specific difference in means other than 0, the hypothesis are written as the difference between the population mean is different from the specific number. For instance, the claim that the mean of the age nursing students community college MUSA 1 are 3.2 years older than those at the University of the MUSA 2, hypothesis would be h of 0 is mu minus 1, mu sub is 3.2, and then h of 1 is mu sub 1 minus mu sub 2 is greater than 3.2. Okay, so yeah. So now the formula, the Z confidence interval for difference between the two mean this time. So we are using the same problem. So this is a formula that we're going to use, okay? So, and then for the problem we have, so we are using the same problem. But this time, alpha is going to be the 1 subtract 0.95, which come out as 0.05. But we need the alpha over 2 as a z-score, which is 0.025, okay? So we are using the example 2. So x of r, x of 1 minus x of 2, subtract t sub alpha over 2 square root of sigma sub 1 square and 1 plus sigma sub 2 square and 2, which is between the mu sub 1 minus mu sub 2, and then x bar 1 minus x bar 2 minus plus g sub alpha over 2 of mu sub 1 sigma sub 1 square and 1 plus sigma sub 2 square over n2, okay? All right, so plug it in. So I got 22.2 minus 22.3. And then g sub alpha over 2 is going to be 1.96 if you use the area of the 0.025. And then you will get 3.68 square over 32, 4.7 square over 32. And then mu sub 1, mu sub 2, same number, 22.2 subtract 22.3 plus 1.96 of 3.68 square over 32 plus 4.7 square over 32. Then when you simplify, it becomes negative 2.2. Mu sub 1 minus mu sub 2 is 2.0. So since the mu sub 1 and minus mu sub 2 is, you got a 0, right? Because one is inside the negative, one is inside the positive. So what you can conclude that is the confidence interval contains 0. So the decision to not reject the null hypothesis. So the result agrees with the previous result. So it must be the same conclusion though. All right, thank you for listening.